In this video, we're going to talk about objects in free fall. Two assumptions we're going to make with these types of problems is number one, objects fall due to the acceleration of gravity. And we've talked about that in the class before. The force of gravity pulls objects toward the center of the earth, straight down toward the ground. And number two, air resistance is going to be ignored in these problems. So we won't factor in air resistance. All right, I got a couple problems here that we're going to go through together, and then I think that as we work a couple of these, they'll become easier, and you'll see the process, and you'll be able to work them a little bit easier on your own. But let's read this first problem. It says, to find out how high a bridge is, you decide to drop a rock off it and see how much time it takes to hit the water below. If it takes 4.7 seconds to hit the water, A, how high is the bridge? And B, how fast is the rock going right before it hits the water? On all of these projectile motion problems, I think the best place to start after you read it the first time is to start with a picture that illustrates what's going on. And so we know there's a bridge. Let me do my best attempt at drawing the bridge here. Okay, we've got the road. Okay, and then underneath the bridge there's some water. Okay, and you're standing up here on the bridge, and it says you're going to drop a rock and time how long it takes for it to hit the water. All right, once you've got your picture that shows the illustration of what's going on, step number two, what I always do is to just list all of the variables that we know is taking place. And it told us in the problem that it took the rock 4.7 seconds for it to hit the water below. And so that's one of the variables that we know. Let me switch colors and list all the variables here in a different color. Okay, so the first variable, if we are dropping a rock that we need to know, velocity initial is going to be 0 meters per second. If you drop something, it's going to start off at the speed or the velocity of 0. And that's something that you'll see over and over. But yeah, just got to remember, if you're dropping it, its velocity initial is 0. Okay, the point at which we drop it, we're going to call that point displacement initial. And I always call that point from where we're starting 0. Okay, and we know that it's also going to have a time initial, and time initial by definition is 0. So 0 seconds, that's when we're going to start timing it. All right, and we also know one more thing, acceleration. The rock is going to be accelerating, and acceleration in this case is due to the acceleration of gravity, so it's going to be equal to g, which we've talked about in the class before, and that's going to be equal to 9.8 meters per second. And one more thing about sign notation on these problems, I always like to call everything that's going up positive, so it'll have a positive sign, and everything that goes down negative. And in this case, the rock is accelerating downward as it's in free fall, so that acceleration is going to be negative 9.8 meters per second squared. Okay, and so let's list some other things that we know about this problem. Time final, when the rock hits the water, it told us in the problem that it took 4.7 seconds for that to happen. So we already know that, 4.7 seconds. We don't know the final velocity, so velocity final, when it hits the water, we don't know, so I'm going to list that one. And displacement final. The point at which it hits the water, how high the bridge is really, we don't know. And so we're going to solve for it. Okay, and that's all the variables that we know of in this situation. So once you have all those listed, then we come to the equations. And I'm always going to give you these 5 equations, and your job is to pick which one you can use to solve for that situation. So let's just go through it together, and I'll show you how I do it. Equation number 1 says that we can only use it when velocity is constant. And we know that there's acceleration here, so acceleration is changing, it's getting faster as it falls. And so we cannot use equation number 1. just a little side note with equation number 1, we're only going to use it for objects that are traveling horizontal. And so in this case it's definitely vertical since you're dropping it, and so we don't use that, equation number 1. Equation number 2 now, remember we're trying to solve for displacement final, and if you scan through equation number 2 you don't see displacement at all, so we're not going to use that one obviously. Equation number 3 has displacement, and this velocity here is velocity final. We don't have velocity final, so we can't use equation number 3 because there's 2 unknowns. We don't know displacement and we don't know velocity final, so we can't use it. Equation number 4 is really our equation that we're going to use most of the time. And so let's see if we can use equation number 4 with this problem. It has displacement, which we need. We know velocity initial, it's 0. We know the time. We know acceleration, and we know time. So in this case we can use equation number 4. And so let's just set that problem up right now. Equation number 4 says that displacement is equal to velocity initial times time plus 1/2 at squared. And so when I substitute these numbers in, our displacement we don't know, so I'm going to call that d. Velocity initial, when we drop the rock, it's 0. And anything times 0 is 0 itself. So this whole term I'm going to just leave off because it's 0. Okay, we got the 1/2, so I'm going to bring the 1/2 down. Times a, our acceleration in this case is a negative 9.8. 9.8. And our time is 4.7 seconds, and so 4.7, but remember, always remember to square that time value here, so a little square. And so now we can just use our math skills and a calculator to figure out what the displacement is. So my calculator says the displacement is equal to a negative 108, so negative 108.2. And displacement is always measured in meters, so remember to throw the units on with displacement. So the answer to A, how high is the bridge, I guess if you're talking about height, it would be 108.2 meters, and that would be positive. But if you're talking about the displacement of the rock, it's negative because the rock ended up below where it started. So it's a negative 108.2 meters. All right, now let's see if we can solve B. It says, how fast is the rock going right before it hits the water? And so on B, what we're looking for is how fast it's going final. So velocity final is what we're looking for. Okay, so let's keep that in mind and pick an equation again that has velocity final in it that we could use. Okay, equation number 2 has velocity final in it, and so if we take velocity final is equal to velocity initial plus acceleration times time. And now we just plug in the numbers that we know. So velocity final is equal to, velocity initial is 0, so we're just going to leave that off. Acceleration is a negative 9.8. And time was 4.7 seconds. And so calculator again, negative 9.8 times 4.7. And my calculator says that velocity final is equal to 46.1, but it's a negative 46.1 meters per second. And again, it's negative because the rock is falling down, and we called that anything down was negative. So anyway, that's how you solve a problem like this. You just, I think if you draw a picture, list all your knowns, your unknowns, and then go through and pick the equation that works best for you, they're pretty easy problems. So hopefully that will help you with those types of problems. There is one more that I'd like to go through in this video, and it's right here. It says you throw a football straight up with an initial velocity of 26.8 meters per second, which is 60 miles per hour. And it says, how high does it go? So again, using the same convention we did last time, I'm going to start off by drawing a picture. So here you are, and you're throwing a football. Let me see if I can draw the football here, straight up into the air. And so if you throw it straight up in the air, we know it's just going to follow this path straight up. It's going to slow down as it gets to its highest point, and then at some point up here, at its highest point, it's going to change directions and then come back down. Okay, so now let's list all of the variables that we know. Okay, it told us in the problem that the initial velocity that you threw it with was 26.8. So that's velocity initial is equal to 26.8 meters per second. Time initial will always be 0 seconds, and displacement initial, the point at which you release the football, is always, I always like to call that point 0. Okay, we know it's going to go up, and it's going to have a displacement final, which we don't know. It's going to have a time final, which it doesn't tell us that either. And it's going to have a velocity final. And velocity final it did give us. Oh, it did not give us. But that's the key point of these problems. Anytime you throw an object up, it's going to go up and up and up until it reaches its highest point. At its highest point, that velocity for that instant in time is 0. So we do know velocity final, and we're just going to call that 0 meters per second. Okay. And what it's really asking us for in this problem is how high does it go? So I'm going to circle displacement final. That's really what we're trying to figure out. Okay. And we do know one more thing, and always with free fall problems we know that acceleration is equal to a negative 9.8 meters per second squared. Okay, now we've got the picture, we've got all the variables listed. Now let's pick an equation that will work and help us solve for what we're looking for. In this case, displacement final. How high does it go? So remember, equation number 1 we can't use because that's only when there's constant velocity or horizontal projectile. So we can't use that. Equation number 2, let's see if we can use it for displacement. But it doesn't have a displacement anywhere in this equation, so we can quickly rule that one out. Equation number 3 has displacement, a final velocity, which we know, an initial velocity, which we know, but it doesn't have, we don't have time. And so there's 2 variables that we don't know, so we cannot use equation number 3. Equation number 4 we can usually use with most of them. Let's see if we can use it. We don't know displacement. We know the initial velocity. We don't know time. So there we go. We have 2 unknowns. We cannot use equation number 4. So equation number 5 must be the one we can use. Let's see if we really can. Velocity final we do have. That'll be 0. Velocity initial it gave us. We know acceleration, and the only variable we don't know is displacement. So let's go ahead and use equation number 5 to solve this problem. Okay, so velocity final squared is equal to velocity initial squared plus 2 times acceleration times displacement. So our velocity final at its highest point, remember our velocity is going to be equal to 0. So 0 is equal to, velocity initial was 26.8, so 26.8, and remember that value is squared. So we'll write the square root sign, or the exponent of 2, sorry, plus 2 times the acceleration, which is a negative 9.8, times the displacement. And displacement we don't know, so I'm going to keep calling it d. Alright, so if I simplify this a little bit, 26 on my calculator, 26.8 squared is 718.24. So let me write that. So 0 is equal to 718.24. And then we're going to have 2 times negative 9.8. 2 times negative 9.8 is equal to minus 19.6. So I'm going to write just a negative sign, 19.6 times d. Now if we solve this equation, it's just one variable. I'm going to slide this, add 19.6d to each side and make that positive. So 19.6d is equal to 718.24. Now to solve for d, I'm going to divide each side by 19.6. So 718.24 divided by 19.6. And that will give me what d is equal to. So displacement is equal to, in this case, 36.6 meters. And remember, displacement is always measured in meters, so 36.6 meters is how high that football will go if you throw it with this initial velocity. So hopefully that helps. We've gone through a few different scenarios and picked some equations. But always remember, if you draw a picture, list all your knowns, variables, and then pick your equation that will work, I think you'll have success with these types of problems. For your video physics assignment, what I've got for you is a couple of questions that will follow. I'll scroll through them very slowly so you have time to write them down. But yeah, good luck. If you do need help with them and you're just not figuring it out, feel free to stop by anytime and we'll solve it together. Thank you.